Okay, so there were some questions about 7b as well. So I thought I'll go through that. So for 7b, the question is, as you see on the right, it's pretty similar. I goes from I1 to n, j increments by multiple of 2. J goes from n to 0, it divides by 2 every time. And k goes from j and goes up to n, and every single time it increments by 2. So the outer loop, it should be it should be clear that this will be log n, and the inner loop, the second j loop, it should also be log n. The challenge will then be in the inner loop. How do we ascertain what's the complexity there? So let's say that it increments by 2, but actually this is just a distraction. So let us do the simple case of k incrementing by 1 each time. So when k increments by 1 each time, so let's do a little bit of unrolling. When j is equals to n, as in the first case, k doesn't run at all. So k fails the condition, and k doesn't run 0 time. And when j, the next time it runs, is n by 2, k will run for n by 2 times. So assume that j will start with n by 2, it runs all the way to n. So k will run for n by 2 times. And let's look at the next case when j equals to n by 4. When j is n by 4, k will run n by 2 plus n by 4 times. Why? Because it runs from j all the way to n of k. When j is n by 4, it means that k will run 3n by 4 times. Okay. When j is equals to n by 8, now we see that k will run by 3n by 4 times plus 3n by 8 times. So which means that k actually runs by 7n by 8 times. The interesting thing is, right now for 7b, it runs from j all the way to the end of n. So we now notice a pattern. Excuse me. Other than the first time, k always runs a minimum of n by 2 times. We can make that assumption or induction that this happens. And right now, and that was the analysis when k increments by 1 time, or rather when k increments by 1 each time. If you go back to the question of having k increment by 2 each time, then it will mean that for each inner loop, k will run a minimum of n by 4 times. So instead of n by 2 if k increments by 1 each time, k will be equals to n by 4 if it increments by 2 each time. Either n by 2 or n by 4 are big O of n, hence the inner loop is big O of n as well. So important thing to note, you might be confused about between this and 7c, but in 7c you notice that the inner loop, it runs maximum n by 2 and it decreases every single time. The converse is true in fact for this question. The converse is true as in it runs for n by 2 times, and every single time it increases once again. So yeah, and so we kind of get a minimum of n by 4 times every single time it runs. So, and in 7c, the number we got log n for both the second and the third loop, but in this case the 2 loops are calculated separately. Why? Because for every single time j runs, k runs for n by 4 times minimally. Every single time this runs, this will run for n by 4 times. So if this runs for 2 times, it will run for 2 times n by 4 times. 3 times, it will be 3 times n by 4 times. In total, we know that this runs for log n times. So this whole thing runs for n times log n times. We know that this is also log n, so the entire thing is n times log n times log n, which is n times log n square.